What if we were to reveal to you that you may, for a time, inhabit a completely distinct universe from your neighbor? You might perceive this notion as eccentric, but there is compelling evidence to support such a claim. Within the vast expanse of our universe, there exist innumerable possibilities ranging from those unfolding right at your doorstep to those triggered by the musings within your mind. Keep your focus, for we are on the verge of unveiling the scientific substantiation for the presence of parallel dimensions within the multiverse. Welcome to Spaceverse, the ultimate destination for space enthusiasts. Dive into the cosmos with us as we unravel the mysteries of the universe, explore cutting-edge space tech, and meet the brilliant minds behind it all. Subscribe now and embark on a cosmic journey like never before. So let's start. Can we not recognize the striking patterns in history? Millennia ago, humanity believed the Earth to be a flat disk, with the sun and moon appearing as mere points of light traversing the arching firmament. Later revelations unveiled the spherical nature of our planet, with stars and galaxies expanding our understanding. With each epoch, our conceptions have evolved, guiding us toward a broader comprehension of reality. For a prolonged duration, the sun was perceived as an enduring constant, which is destined to shine indefinitely. However, contemporary knowledge reveals the ephemeral nature of stars, as they are born and extinguished, and galaxies intermingle. We are now compelled to confront the likelihood that our universe is but one of a multitude, although the existence of other dimensions and realms was not overtly acknowledged. Evidence from diverse cultures and historical periods suggests their presence. These propositions may seem implausible to those inclined toward rationality. Contemporary arguments may scrutinize these ideas through the lens of ancient wisdom, references to mythical entities such as fairies and elves, and unexplained archaeological discoveries. Conventional natural scientists may dismiss the concept of a multidimensional reality as either nonsensical or a product of fanciful imagination. Yet, as we examine the current state of knowledge across various fields of natural science today, embracing an open-minded perspective, we must concede that the indications of parallel realms, alternate dimensions, and the multiverse are steadily growing in density. Quantum physics plays a pivotal role in this unfolding narrative. This branch, focused on the tiniest constituents of the universe, has uncovered a remarkable revelation. When matter reaches a certain threshold, it divides into an enigmatic yet highly predictable entity known as quanta. These quanta serve as the fundamental building blocks of our reality, adopting a wave-like form beyond a specific threshold. While this might initially strike non-scientists as fascinating, physicists understand the profound implications. The certainties, solidity, and well-defined nature of our previous understanding blur into a realm of potentiality. This indeterminate potential harbors even more captivating attributes. In fact, researchers grapple with the impossibility of ascertaining the precise location of these wave-like entities. It remains a conundrum whether these waves persist within our spatial confines, if space itself dissolves at this threshold, or if these particle waves can simultaneously give rise to multiple coexisting realities. The concept of the many worlds theory. This theory involves the existence of parallel universes and has its origins in 1954 when Hugh Everett III, a student at Princeton University, introduced the idea that parallel universes exist and bear resemblance to our own. These parallel universes diverge from our own, creating a network of interconnected dimensions. In this framework, it's plausible that when your neighbor who has interacted with you in your universe suddenly turns away in the morning, and they might, at that moment, be residing in a completely separate universe via imperceptible transitions. This audacious theory presents a wealth of captivating and practical implications. For instance, in parallel universes, historical events like world wars could have unfolded differently. If we take this theory seriously, it's even thinkable that prehistoric creatures like dinosaurs continue to exist in parallel universes due to temporary intersections of realms and dimensions. Reports of sporadic encounters with dinosaurs or enigmatic beings like Bigfoot may find their roots here. Furthermore, archaeological discoveries including depictions of humans coexisting with dinosaurs in ancient pottery or the occasional emergence of modern objects within ancient geological strata can be attributed to this theory. In theory, it's even within the realm of possibility for two nearly identical versions of our Earth to sporadically converge, much like galaxies colliding and merging into a singular entity. String theory and the many worlds theory. Initially, numerous individuals harbored doubts regarding Everett's concept. It appeared too bewildering, far-fetched, and beyond the grasp of the human intellect. Nevertheless, additional scientific discoveries subsequently lend support to these ideas. Quantum physics delves into our familiar world at the subatomic level, where particles are at their tiniest. Physicist Werner Heisenberg introduced the notion that the act of observation itself influences the behavior of quantum matter. Another physicist, Niels Bohr, further corroborated this concept. Consequently, the realm of science has had to recognize that quantum particles theoretically exist in multiple states simultaneously, and that our observation guides their actions, compelling them to adopt a specific state at any given moment. Essentially, our tangible experiences hinge on our mindset, thoughts, and consciousness. Through various experiments, quantum physics has illustrated how every choice and action in our reality can lead us to alternate realities, often unnoticed in our day-to-day existence. Everett's approaches have faced persistent scrutiny due to their incompatibility with fundamental perceptions of time and physics. Nevertheless, we must concede that time remains a somewhat elusive yet comprehensible dimension within the realm of physics. At the quantum level, both time and space shed their conventional meanings and can extend into realms of infinite temporal and spatial possibilities. Up until this juncture, the field of physics has been grappling with the challenge of bridging the understanding of quantum mechanics at the microcosmic scale with the macrocosmic phenomena of our vast universe. This is where string theory comes into play, as it endeavors to bridge the gap between these two distinct disciplines and provide a comprehensive portrayal of our world. In the framework of string theory, the foundational building blocks of matter are not minute particles, but minuscule vibrating strands or strings. These strings extend beyond the familiar dimensions of space, incorporating more than the customary three, and encompass an additional temporal dimension. If these principles hold true, our world would encompass no fewer than 10 spatial dimensions. But what about the inception of the universe, often referred to as the Big Bang? According to Everett's many worlds theory, whenever a choice is made or a measurement is taken, the universe undergoes a division into distinct branches. Each branch encapsulates a conceivable outcome or reality. This implies the existence of an infinite number of parallel universes in which every feasible amalgamation of events and decisions unfolds. Initially, the idea of tracing the universe's origin, or what was once believed to be its origin, seemed to contradict this theory. Nonetheless, evidence of a starting point, the Big Bang, was stumbled upon by scientists who observed the universe's expansion. Investigations into cosmic background radiation unveiled an early cosmos characterized by extreme heat and density. Preceding the actual bang, a quantum fluctuation is presumed to exist, albeit only partially explicable through scientific means. While the concept of a starting point initially appears to challenge the notion of multiple worlds within a single universe, recent developments have raised doubts about the conventional view of the Big Bang. The James Webb Space Telescope was anticipated to provide evidence supporting the Big Bang theory, but it left scientists disillusioned. Instead of confirming the theory, the telescope revealed the existence of galaxies at a point in time when they should not have existed at all. As a result, it has become evident that there may be shortcomings in the assumption that the Big Bang marks the inception of our cosmos. In contrast, advocates of string theory and the multiverse theory have discovered indications of additional spatial dimensions within the universe's inflation. Some of these dimensions may exist solely in a computational form, compacted within a fraction of time. These dimensions are so minuscule that they elude direct perception. Visualize a slender tube represented by a single line. Upon closer examination, we discern that this line is not truly straight, but is contorted into an additional minuscule dimension. While these coiled dimensions remain compact and concealed, they might harbor concealed alternative realities. The manner in which these strands vibrate and propagate within these coiled dimensions is believed to manifest distinct characteristics in observable matter within our universe. However, it's essential to note that these theories have not yet achieved definitive validation. Furthermore, some researchers have identified hints in their calculations related to the Big Bang, suggesting that not just one but conceivably three or even an infinite number of universes came into existence at the initial point. Some of these models project that these alternate worlds may substantially deviate from our own. Whether they are exceedingly minute or governed by entirely distinct physical laws, these worlds may remain beyond our reach, and we may not possess the capacity to fathom or elucidate them. Conversely, other theories propose that we share connections with and even inhabit an assortment of alternative dimensions within the multiverse. All of these potentialities coexist harmoniously. Among them, you can find worlds that closely resemble our own in countless variations, alongside universes that are wholly dissimilar in nature. An intriguing inner dimension of our planet. In the frigid expanses of Antarctica, scientists conduct measurements on streams of neutrino particles originating in space. Utilizing NASA's Antarctic Impulsive Transient Antenna, affectionately known as ANITA, researchers employed a colossal balloon to monitor these neutrino swarms in the high, arid atmosphere of Antarctica. Unexpectedly, the antennas detected a flow of low-energy particles, or neutrinos, emerging directly from Earth's core. It's important to note that neutrinos possess the capability to traverse only meager forms of matter, unable to permeate the entire globe. This implies that high-energy particles are exclusively discernible when they reach Earth from outer space. The recorded data suggested the existence of a parallel universe, with its intersection believed to reside somewhere within our planet. This particle stream even furnished evidence that tau neutrinos had embarked on a reverse journey through time in the universe of particle origin, signifying that time essentially flows in a retrograde manner, or the temporal axis within this cosmos is inverted in comparison to our own. Exploring black holes and white holes, scientists often rely on theoretical calculations and simulations to uncover the enigmas of the universe. This approach is driven by the limitation of direct observational opportunities. For instance, Albert Einstein made mathematical predictions about the existence of black holes long before the discovery of the first actual black hole. Similarly, researchers have postulated that black behemoths in alternate dimensions or universes might conceivably possess counterparts in the form of white holes. In these theoretical models, white holes are depicted as entities that repel matter and light, in stark contrast to black holes which ensnare matter and light within their gravitational grasp. White holes are hypothetically conjured when notions of time reversal within other dimensions are invoked to elucidate previously inexplicable phenomena within our cosmos. This characteristic of our universe offers an intriguing indication of multidimensionality. Yet, as we endeavor to decipher the universe's mysteries, each solution begets fresh inquiries and alternative perspectives on the cosmos. Quantum physics underscores the notion that diverse expectations yield contrasting outcomes and worldviews. According to quantum mechanics, a physicist can, at a particular juncture, validate these hypotheses through empirical observations in their own reality, potentially leading to the attainment of the Nobel Prize and a distinguished career. In an alternate universe, however, the proof may remain elusive, or other scientists may substantiate their own Nobel Prize-worthy claims. Do you consider this evidence to be meaningful, and can you envision the possibility of consciously shaping reality to our advantage? And that's it. Thanks for watching Spaceverse. If you enjoyed this cosmic adventure, don't forget to hit that like button and share our interstellar content with your fellow space enthusiasts. Until next time, keep your eyes on the stars and your curiosity boundless.